Hi and good afternoon, everybody. Many thanks for joining us today. I hope everyone can hear me. Today I'm talking about retaining wall design using the MasterKey retaining wall module. My name is András Körbély. I'm a sales engineer here at the Master Series. Before I start my presentation, I would like to quickly share some practical information about the GoToWebinar. The control panel can be hidden with the red arrow button. Questions or messages can be sent with the chat option. Feel free to type in your questions at any time during the webinar. My colleague Patrick will answer them during the session, but I will also review the questions at the end of the webinar. As usual, this webinar is being recorded and will be posted to our channels and sent out to your email address. Okay, let's start with a quick overview of what is a retaining wall. Retaining walls are structures designed to support soil or other grain materials laterally, so that it can be retained at different levels on the two sides. A well-designed retaining wall makes the area above and below usable. Let's see quickly the parts of the retaining walls. So here we have the stem, toe slab, and the heel slab. The toe and the heel slab form the foundation of the wall. Some walls have a nib to prevent it from sliding. Let's quickly see the types of the retaining walls that we can design using the MasterKey retaining wall model. The first type is the gravity retaining wall. This type of wall retains the soil with its own weight, usually built from stone, concrete blocks, masonry, or even plain concrete. The second type is the cantilever wall. This is the most common type of retaining wall, usually built from reinforced concrete, cavity-filled masonry, reinforced hollow block, etc. The third retaining wall type is the counterfort wall. This type of stiffened wall has inner face piers called counterforts, which are hidden in the retained earth. And the fourth retaining wall type is the buttress wall. This is similar to the counterfort wall. However, the piers are on the top side. Now let's look through the failure mode of a cantilever retaining wall. The first failure mode is the overturning. In this failure mode, the edge of the toe will act as a center of rotation. The lateral pressure from earth pressure and surcharge will act as overturning moment, while the self-weight of the wall and the soil on the heel will act as restraining moment. We completely ignore the variable surcharge load from the restraining moment. The second failure mode is the sliding. All lateral loads try to slide the wall. The restraining effect against the sliding is mainly provided by the friction between the bottom face of the base and the soil below. And the third kind of failure mode is when the soil below the wall fails in bearing pressure. The ultimate bearing pressure capacity of the soil is usually provided in the geotechnical report. Okay, after this short introduction, let's move on to the MasterKey retaining wall module. Okay, so So this is the user so this is the MasterKey retaining wall module. The user interface is pretty simple. In the middle of the screen, you can see the dynamic graphics and the detailed design output. Once we change any information in the editing area, the graphic dynamically will be changed. If the background is white, then this indicates that all design checks are passing. However, we have blue background in this case, which means some checks are failing. The top system of the editing area here, the bottom of the screen, gives us a clear overview of the different functionalities of the program. But before we start designing our retaining wall, let's look at the design code. So here in the main menu, here we can find the available design code. The retaining wall module can design to the Eurocode, the British standard, and to other international standards such as the Irish code. And the retaining wall module also can calculate the highway loads on the retaining walls in accordance with the British code and the Eurocode. In our current example, we are going to design to the Eurocode. Okay, let's start designing our reinforced concrete retaining wall. So I'm going to start with this very basic wall. Let's say it's 2.5 meters height to the upper soil. Here in the wall data tab, here you can change all the parameters. So it's all the parameters in millimeter unit. So that's why it's 2,500 here in the wall data. We have 500 mm projection above the ground here and here, and there is a 600 mm of soil on the lower side here, and here you can change of it. And we have water table at 1200 here, and here you can see on the graphics. Our basic load is a 10 kN per square meter surcharge. So you can see here in the detailed report, here's our surcharge. All the default loadings and settings can be found here in the default tab. So here is our minimum surcharge. This is the 10 kN, which is automatically used and applied on the wall. Let's go back to the wall data. At this stage, we don't know how much of the heel and how much of the toe we need. Let's say both are 500 mm. So here are the 500 both sides. Before we start designing it, let's go and have a look at the soil data. Start with the backsoil. So soil friction is 30 degrees, no cohesion, 18 kilonewton, soil density. So these are the default soil data for the backsoil. Base soil here 30 degree frictions, and in case of base soil, as you can see, we have two ultimate bearing resistance capacity, one for the back and one for the front. If we put in a single value, then we use the same for both. So now in this case, the 100 kilonewton per square meter used for both back and front soil. And there is an option to set M1 and M2 bearing capacity for the different Eurocode retaining wall combinations if you want. We have 6 load cases. This is 6 load cases of the Eurocode are all ultimate load cases. and the soil pressure cogs for these should be compared to an ultimate soil bearing resistance entered here on the soil data tab. Not the permissible bearing pressure that many engineers have been used in the BS design method. Since these cases are ultimate, there is a further need to check the service load case for bearing and settlement. On the default tab, there is a tick box which is introducing this additional load case. By default, it is checked on. So if we check this on, the service bearing pressure case, then we can see that a new case 7 service based pressure check has been introduced. So let's go back to the soil data. So instead of a permissible or service bearing pressure of, let's say, 100 kilonewton per square meter as for the British standard, you would enter an ultimate value of, say, let's say 200 kilonewton per square meter. Yes. The service bearing resistance for the case 7 service check is calculated from this ultimate bearing resistance by dividing it by a factor of safety of 3. The 3 is generally accepted value. However, you can change it. You can overtype it again here on the default tab. So here you can see this value of 3. Okay. So now we have our soil. We can step back to the wall geometry, to the wall data tab. So as we can see, our wall is failing. So we can clearly see here in the summary of result, and as I mentioned, the blue background also indicates that there are some failing checks in the calculation. So what we need to do is, first of all, to make the heel longer until the wall stops sliding. So let's start increasing the heel. And as you can see, so I'm clicking on the button and changing the parameter, then the dynamic graphic is automatically updated, and the program recalculate the design, the calculation. And as we move up, we get a situation where suddenly no overturning here and no sliding. Yes, here it is. So you see no overturning issue and no sliding issue. However, bearing pressure is still a problem. So you can clearly see here. So let's continue now with the toe. So if I step up to 600, then you can see no. You can see that no bearing pressure problem. Okay, so 600 works, but I actually make it to 650, which gives us 2300 mil base. Okay, so stability-wise, our retaining wall is working. What we need to satisfy now is the reinforcement in the wall and the base. So as you can see, and the wall inner face steel and the base top face steel are failing. So let's go to the reinforcement tab. And first of all, at this point, it might be worthwhile to decide our concrete grade, which is, let's say, C3240 concrete. Steel grade 500 definitely be steel, and I'm gonna go for 15 mil covers. So reinforcement 10s and 200 are not good enough, as you can see. Let's try 12s for the wall inner face. So this is the soil face. Okay, it seems good. However, if we scroll down to the reinforcement calculation, then you can see the maximum distance. The maximum distance between the rebars should be less than 184. So that's why I will go down to 150, for example. Okay, so the wall reinforcement looks good. And for base, I'm gonna go down again to 10s at 150, and now this is satisfactory. So now it's good. So, and that is, as you can see, that the background turned into white, and this is telling us that our reinforcement works, our stability works, so our wall works. Okay. Now, if we want, we can schedule and export our reinforcement on the exporting tab. First of all, we can select the type, and we can select the style of the reinforcement, both for the wall and the base. We can use U-bar and straight at each end, or L-bars with straight and other variations. So I will use the U-bar and straight for both the wall reinforcement and the base reinforcement as well. Okay, the retaining wall is designed as a 1 meter depth into the screen. When exporting the reinforcement details of the wall, you can specify the full depth of the wall into the screen as the wall length. This length will be used to accurately draw the elevations of the wall and the base, and for the detailing of the reinforcement in the bar scheduling, in the bar bending schedule. So here we can set our length, so it's a 5 meter default. So if you want, you can overtype it and specify your exact retaining wall length. Okay, let's export our reinforcement into the XF file. So by clicking on this export button, we can create our drawing. So yes, it will be a DXF file. Let's export it. The program automatically opens up and the AutoCAD. And here it is. Here is the drawing. Okay, it's still working. Right, so it's ready. So here you can see the sections. Here you can see the section of the wall. Here are the reinforcement. This is the front elevations and the plan view. So here you can see all the main reinforcement. Okay, let's go back to the master series and let's schedule it. So we can also schedule the reinforcement. Oh, sorry, I clicked schedule. Yes, here it is. So we can also schedule the reinforcement, and this will schedule the bars in line with the DXF output. So the line up with the correct bars. So it's line up with the correct bars and the bar marks. So you can see here, you can see the same bar marks as we have here in the drawing. So you can clearly see the shapes. So here we only need this U bar, and here you can see the parameters. So we have 3 types of U bars, and we have 4 straight reinforcements. Okay, so this is how easy to design a reinforced concrete, a simple reinforced concrete retaining wall in the master series. So now let's look at the other types of walls we can design with the MasterKey retaining wall module. So this is my first example. It is still a reinforced concrete retaining wall, but in this case we have got 2 props. We've got a prop at base here, which would get rid of the sliding. If we can prop it up against something else, such as a house or another retaining wall. And we also have a prop at the level of the upper soil to resist overturning. We have a prop and ties tab, and here you can specify your props. So here we have the prop at base, and then you can specify up to 5 props along the wall. Okay, let's move on. And this is my second example. It is still a reinforced concrete retaining wall, but we no longer have props, but we have a sloping and layer backsoil. So this is the upper backsoil, and this is the lower backsoil with the water table. If you look at the soil data tab, then you can see that the backsoil is layered, and we have an upper layer and we have a lower layer, and the lower layer is 2 meters height and sloped 5 degrees. And now in this example, as you can see, we have nib as well here. Let's move forward. And now it is a masonry filled cavity reinforced masonry retaining wall. So we can design solid filled cavity and filled cavity retaining walls. So in this case, here we have a 200 mil filled cavity. So if you go to the masonry tab, then here you can see here where you can specify outer leaves and inner leaf material. Here is the thickness, the outer leaf, and here you can specify your cavity. In this case, we have a 200 mil filled cavity. Both our outer and inner leaf is 100 mil. Let's look at a quick look at the reinforcement. So in the cavity we have 12s and at 150, and this works. Okay, and this is my next example. This is a step wall. Yes, we can calculate. We can design step walls as well, because in this case we have no reinforcement. So as you can see, we don't have any wall reinforcement. So that's why we need quite a distance to make it work. The step wall, the stepping can be specified here on this on the wall data tab, and both the inner leaf and the outer both the inner side or the outer side, or both stepped. For a smaller work, the step Masonry retaining wall can be efficient. Okay, and this is my next example, which is a concrete retaining wall again. However, now we have a complex loading. So we have loads on the soil, as you can see here. So here you can see, here we have the loads on the soil, such as a strip foundation of a house or a vehicle load, for example. So possibly in this example, this is the axial forces of a vehicle. And we can also put loadings onto the wall here or outside the wall. All the loadings can be found, or the loadings options can be found here on the loads tab. So we can specify line loads. We can specify full and partial UDS or surcharge loads. We can add additional surcharge, and if we have an upstand, then we can specify wall upstand wind as well, or horizontal line loads like a barrier or something like that. So these are the load types or load options. Okay, and the last example is a double propped wall. So as you can see, so this is a double propped concrete retaining wall. We've got a prop at base and a prop halfway up the wall and another at the top of the wall. So if we give a quickly to see the prop and ties, then you can see we have a prop at 3000 mm high and another at the top of the wall. Okay, so that is the retaining wall design using the MasterKey retaining wall program. You can see that we can design a wide range of retaining wall types. Ladies and gentlemen, I would like to thank everyone for attending today. I hope you enjoyed and learned in this short presentation, and see you on our next webinar. If you have any further questions, you can get in touch with us on our usual channel. And if you want to try out the software, just go to the MasterSeries website, fill in a request, and to do so. After the webinar, please do not forget to fill in the short 1-minute survey to let us know how you like the webinar. So, thank you very much again, and goodbye.